in this video, I want you to practice identifying if a substance is an element, mixture, or compound. And if it is a mixture, I want you to know what is it? Is it a mixture of elements? Is it a mixture of compounds? Is it a compound and an element? So let's look at this first box. And in this box we have spheres that represent atoms. And so in this video, each sphere will represent an atom. You notice that all the atoms are the same. They're the same size, they're the same color. Okay, atoms in real life probably don't have color, but we use this model to denote that these atoms are the same kind. So each one's the same, but they're kind of bunched in twos. So that part might be confusing to you. We define an element as a substance made of only one kind of atom. So this is an element, even though there are what we have is molecules of the element. So that's a molecule of the element. Okay, a molecule is when you have two or more atoms that are chemically joined. In this case, the atoms are the same, so it's a molecule, but it's a molecule of an element. And we call this a diatomic element. So each one of these guys is a molecule because there are two atoms in each molecule of the element. So this is a diatomic element. This could be like oxygen, nitrogen, O2. That each molecule would be an oxygen atom and two oxygen atoms joined. All right, diatomic element. Let's look at the next one. The next one has all the atoms are the same kind, so this is also an element. The only difference between the picture above and the picture below is that this one has them arranged pretty regularly and tightly packed. So this is just an element, but it's probably in the solid form. So most elements are metals. So this could be like iron, copper, something like that, likely to be if it's at room temperature. Let's look at the next one. Let's look at this one up here. Okay, now we have something else going on here. We have clearly two different kinds of atoms, but in each molecule, right? So here's a molecule, and here's a molecule, and here's a molecule, and here's a molecule. Each of those molecules are the same kind of, have only just one kind of atom. So that's an element. It might be the substance in the box next door here. Okay, that one. But now we have a different kind of element too. This is also an element because each molecule has just the two red dots that are the same size. So that's a different element. So these are not chemically joined to each other. So this is a mixture of elements. Most of air is a mixture of elements. So like air is a mixture of nitrogen and oxygen. And so most of air is a mixture of diatomic elements. Nitrogen is about 78%. So we would have a lot more nitrogen molecules if this was air, and this is about 20%. And we'd have a lot less oxygen molecules if this was air. Okay? All right, so now that's a molecule of an element. It's a diatomic element. This is a mixture of diatomic elements. Okay? That's an element, and it's in the solid state. Let's look at this one. Okay, this is just an element that's probably in the gas state, but it's a monatomic element. Mono means one. So this could be neon, argon, The noble gases are found as single atoms. They're not joined to each other like diatomic elements. It also could be like a gaseous metal, like you heated a metal until it vaporized. That's possible too. Okay, let's look at this next one. All right, so here, again, we haven't hit a compound yet because in each of these, okay, so that is an element, that is an element. So it's not joined to any other kind of atom. This is one element that I've circled in blue, and then I've circled the other one in black, but those are molecules of an element, so that's a diatomic element. So that's just a mixture of monatomic and diatomic elements. Okay, so it's a mixture of two elements. Let's go to the next slide and look at some where there's compounds and see the difference. Okay? All right. Okay. This is a compound. It's a diatomic compound. Okay? It's a compound because each molecule, so here is a molecule of the compound, and it differs from a molecule of an element, which I'll go to the previous slide and remind you. This is a molecule of an element. I'm up here in red now, so you can see. That's a molecule of an element. Those two atoms have the same, or those two atoms are the same, so that's why it's an element. In this case, these two atoms are different. It's a compound. This is a pure compound. It's a pure substance because all the molecules are the same. Okay, it's just that each molecule has more than two, or has two different kind of atoms chemically joined. You can have more than two and have it be a pure compound as well. So this might be a compound like HCl, okay, where the smaller atom would be the hydrogen atom and the larger atom would be the chlorine atom. That's a pure substance. It's not a mixture of hydrogen and chlorine. It's a compound of hydrogen and chlorine because each unit is the same. A mixture of hydrogen and chlorine would be different. Okay, let's look at the next one. Okay, so here is, again, all the molecules, each molecule has one black dot and two kind of brown dots. They're the same as each other. This is a pure substance. It's a compound. It's not an element. It's not a mixture of elements. Each molecule that I've circled has the same ratio of black to beige dots or brown dots. So this could be like carbon dioxide. Okay, it could be like a CO2 compound, where the little guy in the middle is the carbon and the bigger guy on the outside is the oxygen. So again, each one of those is a molecule of a compound, and it's a pure compound. We don't have any mixtures. Okay? Let's look at what would happen if we took, mixed HCl and CO2. Now we have a mixture of compounds. Okay, we have a each of these being an HCl. Okay, so this is no longer a pure substance. It's a mixture of substances. Okay, the HCl gas has mixed with the CO2 molecule, the CO2 gases. They haven't done a chemical change. A chemical change would mean each the HCl and the CO2 would have altered. So if you mix these two substances and they don't interact with one another, then they just mix. If they get a chemical reaction, you end up getting something new that you didn't start with. That's the difference between a chemical change, which would be a chemical reaction, and then just mixing two different substances and then having them retain their own identities. So this is a mixture of two compounds, one of them being, say, CO2 or whatever this I've circled in blue represents, and the other, say, being HCl or whatever I've circled in black, whatever that represents. I hope this clarifies what the difference between elements, mixtures, and compounds are.